This says that all the y's are less than the line. Oh, wait, all the y's are less than the line. So you shade below.
Wow, that would help me a lot.
I know.
I didn't even do this.
That is just me.
Only when it's in y equals mx plus b does that work. Okay, we'll see more of that. Okay. So this is just the basic parent function of an absolute value, which is a v, and it is solid. You can use that little trick I just said, but if you don't remember, you could check out a different point. Let's try 0, 2. I can't use 0, 0 because the function is on that point. So if I plug in 0, 2, is this a true statement? Is 2 greater than or equal to 0? So I shade this part of the graph. Okay? That's all review. Today we're doing systems of linear inequalities, systems of inequalities, so it's not too bad. We're going to look for overlap in shading when we graph two inequalities. Okay? You've done this before. I know we did it in 8th grade. All right, so this is already in y equals mx plus b form. Way easy to graph. You begin with the 2. You use the slope to get your second point, up 3 over 1. Solid or dashed?
Solid.
According to my little trick, would you shade below or shade above? This is in y equals mx plus b. What do you think?
Below.
Yeah, see how it says the y's are less than the line. So you would shade below. But if you honestly do not get that, just plug in 0. 0, 0. That's a true statement. So lightly shade underneath here, because we got another one to graph.
I'll just do like
Oh, I remember this.
I do remember.
You get to color in Advanced Algebra 2. Okay, so again, to graph this one, you start at 4. Start at 4. The slope is -1 over 1, correct? -1 over 1, so you go down 1 over 1. Dashed line. Now, according to my inequality, it says the y's are greater than that. So would I go above or below?
Above.
Above. And if you just don't know, plug in 0. Why does that not work? What am I doing? Something wrong. Okay. Here we go. Backside. All right, standard form. Let's just whip out a baby table here. If I plug in 0 for x, y is 4. Plug in 0 for y, x is 2. Over 0, up 4. Solid or dashed?
Solid.
Draw it as straight as you can, because this one's going to be a little tricky. Let's plug in 0 for x and y. Does that give me a true statement? No, so I have to shade above. I shade above. This one's already in slope-intercept form, which is handy. You begin with the 3. The slope is -2 over 1. So go down 2 over 1. My lines are not very straight. It's not being very good here. Oh, look at this. If I draw a dashed line very carefully, because my lines aren't very straight, I apologize. They are parallel. But let's see what happens when we shade.
It's going to be below it.
It is below that line. So look, is there any overlap? No overlap. So no solution. okay?
Who's that?
It's tricky, I know. All right, let's do this one. Y is less than 2. What kind of line is this, you guys?
Horizontal.
If I write it as an equal, it's a horizontal, and the Y is 2. It's a dashed line through there. It says all the Y's are less than that, so I shade below. What happened to the absolute value function here? It did what? It moved, I heard it. 1 to the right, yes, okay? So it moved 1 to the right. So we have the same parent function, the vertex just moves to the right, and it is a solid line. You can use the same rule here. What do you think? Where do you think we're going to shade here? It's above it. It's greater. But if you're not sure, let's just test with 0, 0. Let's plug in 0, 0 and see. Does it make a true statement? This becomes -1 and the absolute value is 1. Is that a true statement? No. So 0, 0 is not part of the solution. So we would shade above, and if you do the whole thing, that's fine. And then I would just see that right here is your solution set, where it overlaps. Okay? Now, last one. Oh, look at them all. How fun is that? Okay, it's pretty easy. What kind of line is this? Vertical through 10, correct? And it's solid. Vertical through 10. So color lightly, because we got 4 of them. So it's everything greater than that, so it's just going to go this way. Okay? Then this one is vertical through what? 70. Solid line. And it's everything less than, but we already know that it's not going to go past this. So, because it has to be greater than or equal to 10, right? Okay, now here, you could write it like this if it helps you. What's your intercept there? 0. What's your slope? Okay, yeah, so this is kind of yucky, but couldn't we just do, thanks to Nick Cessio, couldn't you just do 80 over 70? I'm like, oh yeah, you could do 80 over 70, couldn't we? He's really smart, and I just didn't even think of that. I'm like, yeah, that's easier. Isn't it the same thing? If you went 8 over 7 10 times, wouldn't you end up at 80 over 70? You would. So there you go.
Wait, I can see.
So is it solid or dashed? So it's solid from 0 all the way up. I should do a different color, but oh well. Okay, so it says it's all the Y's less than that, so I would shade what? Below. So I'll do that in a little bit of pink. So right now we're confined to this area right here, correct?
It's a triangle.
So far. Now we got one more to do.
So up 20 over 70.
Right on. You could do it like this. Y equals, let's say, 20 over 70, because if we did 2 over 7 10 times, we would end there. So 20 over 70. Up 20 over 70. Solid line. And it's just a hot mess, basically.
So it's this kind of triangle, right?
So this is saying that it's all the Y's greater than that line. So we're confined to this area right here.
No,
It is a mess.
Oh, you're so bad.